Tonight on Dark Matter Nap, we are going to look past the horizon of our lives, past the lifespans of Terran, and face the absolute final chapter of reality itself. When we look out at the universe today, we see a cosmic masterpiece in full bloom. Galaxies are spinning, gas clouds are condensing into brand new solar systems, and stars are burning bright, radiating energy across the void. It feels like a system that will dance forever. But the laws of physics contain an unyielding, cold truth. The universe is not a permanent machine. It had a definitive beginning, and it will have a definitive, absolute end. Every star you see in the night sky is running on a limited supply of fuel. The space separating those stars is expanding every single second, pushed apart by a mysterious, repulsive force. Most people think the end of the universe will be a sudden, catastrophic explosion, a reverse Big Bang. But current astrophysics models tell a much more haunting story. The end of everything won't be a violent scream. It will be a slow, freezing, and agonizingly quiet fade into absolute nothingness. Tonight, we will chart the deep time timeline of our cosmos. We will watch the last stars burn out, the galaxies dissolve, and the very atoms of reality fall apart until time itself ceases to have any meaning. Before we journey into the ultimate dark of eternity, take a second to like this video and subscribe to the channel. It helps us reach more curious minds like yours. Now, settle in, turn off the lights, and let's watch the lights of the universe go out. We currently live in what astronomers call the stelliferous era, the age of stars. It is the golden window of cosmic history where gravity successfully pulls hydrogen gas together to ignite stellar fusion. But this era is temporary. Roughly 100 trillion years from now, the universe will run out of raw hydrogen gas. The massive interstellar clouds that spawn new stars will be completely depleted, used up by previous generations of suns. No new stars will ever be born again. The massive blue stars will die first, exploding as supernovae. Then, sun-like stars will exhaust their fuel, expanding into red giants before collapsing into faint white dwarfs. Finally, only the smallest stars, the red dwarfs, will remain. These tiny stars burn their fuel so slowly that they can live for trillions of years. But eventually, even the red dwarfs will consume their last drops of hydrogen. They will cool down, turning into dark, cold spheres of iron and carbon known as black dwarfs. The universe will plunge into total darkness. The era of starlight will be over, replaced by a silent, cosmic graveyard of dead stellar remnants drifting through an endless night. With the stars extinguished, the universe enters the degenerate era, spanning from 100 trillion to 10 duodecillion years in the future. During this immense stretch of time, the grand structures we see today, the beautiful spiral galaxies and cosmic filaments, will begin to systematically dissolve. Without the light and heat of active stars, galaxies will become tightly packed clusters of black dwarfs, neutron stars, and black holes, all locked in a chaotic gravitational dance. As these dead objects navigate the dark, they will occasionally pass close to one another. These close gravitational encounters will trigger a process called kinetic sorting. In a cosmic game of billiards, the lighter objects, like dead planets and small black dwarfs, will be flung outward, ejected completely into the lonely intergalactic void. Meanwhile, the heavier objects will lose orbital energy and spiral inward, falling directly into the supermassive black holes sitting at the center of the galaxies. By the end of this era, galaxies will completely evaporate. The cosmos will no longer feature structured islands of matter. It will be reduced to a sparse, infinite desert populated only by isolated black holes and lonely, rogue stellar remnants drifting light years apart. At this point in deep time, the survival of any solid matter depends entirely on a fundamental variable of subatomic physics, proton decay. In our everyday lives, we treat atoms as permanent building blocks. A rock, a metal plate, or a dead planet seems stable forever. But theoretical physics models suggest that protons, the subatomic particles inside the nucleus of every atom, have a strict expiration date. They are predicted to have a massive half-life of roughly 1034 years. If proton decay is real, the consequences for the deep future are absolute. Over unimaginable stretches of time, the protons inside the drifting black dwarfs, neutron stars, and frozen planets will spontaneously split apart, dissolving into positrons, electrons, and photons. Solid matter will literally melt away from the inside out. The dead planets will dissolve into clouds of subatomic gas. The black dwarfs will vanish atom by atom. The universe will enter the black hole era. Every single solid object constructed since the Big Bang will be completely erased from existence. The cosmos will be populated by absolutely nothing but black holes rotating silently in a dark, cold vacuum. With all normal matter dissolved, the supermassive black holes will inherit the universe. They will stand as the ultimate kings of a dark empire, some spanning billions of miles across, holding the crushed mass of entire galaxy clusters inside their event horizons. But even these gravitational monsters cannot escape the laws of quantum mechanics. According to a discovery made by Stephen Hawking, black holes are not completely black. They slowly, silently leak energy through a process called Hawking radiation. At the event horizon, quantum fluctuations spontaneously create pairs of virtual particles. Normally, these particles instantly annihilate each other. But occasionally, one particle falls into the black hole while the other escapes into space as radiation, stealing a tiny fraction of the black hole's mass. This process is agonizingly slow. A black hole with the mass of our Sun takes 1067 years to evaporate. The largest supermassive black holes will endure for 10,100 years, a number known as a googol of years. But as they lose mass, their temperature increases and their evaporation accelerates. In their final seconds, the black holes will shrink rapidly and vanish in a sudden, brilliant flash of high-energy gamma-ray radiation. One by one, the ultimate monsters of gravity will pop out of existence, leaving behind an empty room. After the final black hole explodes and vanishes into the dark, the universe enters its absolute final phase, the Dark Era, also known as heat death or the Big Freeze. The phrase heat death is often misunderstood. It does not mean the universe gets hot. It means the universe reaches maximum entropy, a state of ultimate thermodynamic equilibrium where all energy is evenly distributed and temperatures drop to absolute zero. The universe will be infinitely large, completely dark, and totally uniform. Pushed apart by the relentless acceleration of dark energy, the distances between individual particles will grow to scales larger than our entire observable universe today. A single electron will float light years away from a single positron, completely isolated in a vishal, unyielding void. Because there are no temperature differences, no concentrations of matter, and no energy flows, nothing can ever happen again. No information can be processed, no structures can form, and no events can occur. The arrow of time loses its meaning, because a universe where nothing changes is a universe where time has functionally stopped. The cosmos reaches a state of eternal, undisturbed stasis. It is incredibly easy to look at this timeline, to look at the slow dissolution of stars, atoms, and black holes, and feel a sense of profound existential insignificance. The era of complexity, stars, planets, and human life is nothing more than an infinitesimally brief flash at the absolute beginning of an eternity of darkness. We are a temporary pattern emerging briefly before dissolving back into the void. But there is another way to view this timeline. The very fact that our era is fragile, temporary, and bound for maximum entropy makes our existence right now extraordinarily special. We live in the vibrant, energetic springtime of the cosmos. We are the universe noticing itself before the lights go out. We can look through our instruments, chart the stars, and calculate the very laws of physics that will eventually dissolve us. Thank you for joining me tonight on this deep journey into the ultimate end here on Dark Matter Nap. If this exploration challenged the way you look at the night sky, or made you appreciate the fragile beauty of our golden era, please take a moment to like this video and subscribe to the channel. The next time you look up at the stars, appreciate them not because they are permanent monuments, but because they are beautiful, temporary lights shining bravely against an inescapable dark. Sleep well tonight, knowing that our universe still has trillions of years of stories left to tell. Good night, and may your dreams reach far beyond the uncrossable horizon.